So we will start the last lecture of the course, which is essentially a summary lecture of everything which was presented. And so let's start.
Okay. Yeah, since this is the last lecture, is a summary of the basic ideas. I'm not going to repeat the technical details. We don't have the time, and we have already done that. So my basic idea here, you see, I say we are going to visit what I think to be the basic questions of the field, which I list four of them. First, of course, is what is AGI, what you're talking about. The second one is whether this is possible to be achieved. Third one is if you think it's possible, then what is the best way, the most realistic way to achieve it? And finally is whether we want to do it or not, even if we can do it. I say we're revisiting these questions. One reason is actually I have touched all of them during the lecture. Another one is because when I just arrived in Stockholm, I actually gave a lecture, a separate one from this course, on those four questions here at Digital Futures. Okay. But that's before I teach NARS. And here, since we have already covered what our team have been doing, I think we can revisit those questions, which are much more tips compared to my usual treatment of those topics. And also, I believe this fourth question, actually, you can actually ask it for every topic of research, right? And what you want to do, whether it's possible, how, and whether you finally want to do it or not. Okay. So it's quite general. So this is something I have been thinking for years, and now I summarize my most recent idea or way to put about it. First is what is AGI? Clearly, everyone still have different opinion. And my opinion, I have already explained. I think intelligence means to adapt to the environment with insufficient knowledge and resource. I'm fully aware this is not the one that accepted in the field by most of the people, but I still think I have a reason to argue for it, and also because this is the foundation of everything else in this project, as you have seen. So you'll see that this concept of intelligence clearly starts from human intelligence. In some textbooks, they actually divide a different definition of AI into, a group which is more like human. The other group is not that much like human. To me, actually, every definition, as far as I know, starts from human intelligence. It's just people capture or abstract different aspects of human intelligence, which is super complicated for sure. Okay. And also, they abstract it to different levels. So we end up with different definitions. So I'm not an exception there. I start from human intelligence, but you'll see that here I want to abstract to a level. So as the definition will across the boundary, for example, between biological or mechanical system, or across the definition or the separation between individual system and group system and so on. I think those things does not matter because intelligence should be something you have more than one form or more than one concrete implementation, if you put it that way. That's actually not just my idea. That's basically the intuition behind AI from the very beginning. Mm-hmm. I just want to make it more clear. So you'll see that in my description, the difference between my definition with the other people, on one hand, even though the idea comes from human intelligence, I deliberately keep some distance from the details of human intelligence. You'll see in the whole discussion, I'm not using terms like a neuron or I do not refer to things like specific to the human species, like its evolutionary history or its special social structure, and all those kind of things. I think they are human specific property. They're not necessarily properties of intelligence in general. Okay? I tried very hard to not to make it too specific to human, to avoid the result that you draw the circle too small. So according to your intelligence definition, only human qualify to be intelligent. Well, that may make us feel better, right? But it clearly doesn't help the field, and especially it will limit our ability of imagination about other form of intelligence, especially the one that's suitable for a computer system, which at the bottom level is completely different from the detail of human brain, and also it doesn't have the history of human evolution and so on. Okay, some people say, yeah, you can simulate it, but to me, intelligence should not be a simulation. It should be the real thing. Okay? It just you abstract to that level, and you will get the real thing. It's not just a duplicate or some second-hand copy. So that's on one hand, I want to draw the circle of intelligence not too small. But on the other hand, I also want to draw the circle not too big. So that's the problem I see in most of the current textbook definition of AI. They typically define it as some kind of problem-solving capability. The trouble of that definition is not because it's wrong. Okay, none of the definition is wrong. They're all correct. They just each has its own feature or strength or weakness. Okay. The problem about defining intelligence as a problem-solving capability is to draw the circle too big. Okay. It basically covered almost everything in computer science. Okay, whatever you make a computer to do is to solve a certain problem, of course. That also explains the so-called AI effect or whatever name people have used. That is, as soon as you solve a problem, people say, no, that's not AI. Why? It's just because you do it just in the old-fashioned way, or just do computer programming. Just like today, okay, because now suddenly AI become a good word. Now everything is labeled as AI. To me, if you draw the circle too big, you're mixing so many factors together, you miss the point. You miss the key point that distinguish intelligence system from non-intelligent system. I still try very hard to draw that distinction. So you see that for me, intelligence is not about problem solving. You can solve the same problem either with intelligence or without intelligence. So the difference is not what you can do, it's under what situation you can do it. So you see that in my definition, intelligence is actually is a meta level problem. It's not about to play chess or to drive a car. It's about the general problem that if you don't have enough knowledge and resource, what you can do. And this is also what makes this problem domain independent. That's why it's general, because it has nothing to do with in which domain you're talking about. You always have this issue, you always use the same strategy to handle that issue. That to me is what intelligence should be about. The domain-specific solutions, that's what we typically call skills. Okay, that's what you get using intelligence. It's not intelligence itself. Okay. So that's another point I make in this definition. So which of course sounds annoying to many people because maybe according to this definition, many work in the current AI domain, according to this definition, is not intelligent at all. That clearly doesn't sound right to them. But I do have a reason to do that. And it's not because I do not respect their work. I just say we are working on different problems. So I don't want to define intelligence just as a collection of problem-solving skills. So I think that may actually explain better about the definition, and also I think that will give the field a proper identity. That is, to me, AI is not applied statistics. It's not just a special computer programming. It's not cognitive psychology. It's not brain modeling. Okay, it's related to all of them, but it has its own problem. It needs its own solution. So that's what I hope my definition provides. So you see, I already mentioned the working definition does not deny the value of the others. Even recently, I still see some video and some talks. People say, "Oh, there is no such a thing as the true definition of intelligence," which I agree. Okay, it's a said different people can have different opinion, and they're all justified because they capture part of intelligence as shown in the human mind. But on the other hand, I don't agree with the opinion say it doesn't matter. So whatever you say, you can just do it. Okay, just because there's no way for us to agree at this point. So it doesn't matter. What matters is not the name. You can call it whatever you want. It's the direction. It guides the research. Okay, it's this photo. You see, this is a photo I took myself, so there's no IP problem. Okay, so you can say I want to go to North Pole, and the other people say I want to go to New York City. I'm not saying that you're going in the wrong direction. I just want to stress we are different. We are not going to the same direction. So what? So it cannot be evaluated according to the same standard, same milestone, and so on. Okay, that's what many people are doing, are using the success of one approach to criticize another one, which is actually going to a different direction. Okay, so that is wrong. Okay, even though you can say, oh, I just want to go that direction, and that itself, that's not a problem. Okay, but we need to be clear what we are talking about. Okay, if everyone agree or insist the intelligence should be used for problem-solving capability, then I will just use a different word. Okay, that's not the key point, even though I still believe my usage of intelligence actually is closer to kind of like the core of the everyday usage, even though in everyday usage, just like all the other words, it's ambiguous. People are using it for different things. It's just simply because in human intelligence, all of those factors are mixed together. Okay? But the way we're doing it in computer, they become very different from each other. I think that's something that many people still haven't fully realized. Okay? So that's the point I want to make when I'm promoting my work in definition. So the second part is, yeah, is AGI possible or not? I'm sure everyone has seen already until today, there's still a lot of claims on the internet or in publications say that they have proved a true AI or true AGI is impossible. The first issue is, of course, it depends on their interpretation or their working definition of this concept. Okay? Some of the concepts I also think is impossible, but some others I think is possible. So instead of talking about AI as a whole, now let's see some specific criticism. So even our project NARS is still far from finished, I think I can still say that the current practice already answers some of the claim about impossible features. For example, this is quite common, right? Many people still repeat that today. Say computer can only do syntax, it cannot do semantics, it has no access to meaning. So this is behind the symbol grounding problem, Chinese room argument, all those kind of things. Okay, but as I have explained in detail, some detail, in ours, the situation is different. In ours, a concept does not refer to an object in the world. If that's the case, then it will run into the same issue. Instead, a concept captures part of system's own experience. Because of that understanding about the meaning and the concept, we don't have symbol grounding problem because, well, since it comes from experience, it's already grounded on the experience it comes from. Okay? And you can say its understanding is different from mine. Well, that's real. But you cannot say it has no understanding because it's waiting for someone to provide a reference. The symbols or the concept of NARS are not symbols because it does not need an interpretation. Okay. And some of them, yeah, special case, we can still have variable terms. That's a special case. Concepts in general, we don't have this issue. Okay. So the reasoning in NARS is both syntactic in the sense that it recognizes the shape and the semantics because it changes the meaning. It depends on the meaning of the premise and also it changes the meaning of the conclusion. Okay. Every sentence will change the meaning of the terms involved a little bit. And also it uses the meaning of the terms in the premise to a certain degree. Okay. So it's a formal, but it's not pure formal. So that's a possibility that many people didn't realize or never taken into consideration. And that's possible because we already realized, we already implemented. Okay. So another argument, actually this one comes all the way back to the first article of Alan Turing. He criticized one of the version of this, say that computer just executed a program provided by human. So there is no real creativity. Okay, some people still repeat that. On one hand, it's true at a low level. Okay, everything in ours is nothing but a program written by our team, right? There's nothing magical. So the computer does nothing but just follow those programs. But those programs are not the program that at the problem solving level, it does not fully specify how a problem is solved. They're basic building blocks which are combined to solve a problem. Okay, those of you who have followed my lecture should know what I'm talking about. So we don't have problem level, or we don't demand problem level algorithm, which is exactly what insufficient knowledge means. Okay, if you don't know how to solve a problem, then you can still find a way to do it by trying all kinds of possibility, well, roughly speaking. Okay, that's what NARS does. So you don't have to only give it a problem we know for sure it can solve. It will give it a try, but it will not guarantee the success. And that's where actually creativity and the flexibility of the system come from. Okay. Another thing also is quite common for people to argue is computer can only pursue goals assigned by the designer or user. It does not have its own goals. And this is also something we explained briefly. That is, there is a goal derivation process in NARS. So yes, all the initial goals are given by the designer or user. Will not come from nowhere. But this goal derivation process heavily depends on the system's own experience. And since the experience is not fully designed by the designer or not, after a while, the system will derive some goal which is not anticipated by the designer. For good or for bad, right? And so that's something later we will go back to this topic. But anyway, we can claim it's not a system that only solves problem you give it. Sometimes, of course, it's annoying because later after you try a while, you will see it's working on something we don't think is valuable. It will, on the other hand, will ignore the task we assigned to it, which of course need to be improved at the current version. But in another sense, in principle, it's inevitable. Okay. That's what we call original autonomous. You see, autonomy is not only about for the system to find a solution by itself for the problem you're given. A more important sense is the system will find its own problem to work on. And that is possible given the mechanism we built in NARS. Okay. and a whole bunch of other things, like, for example, some people say, oh, computer cannot really have emotion. It should not or cannot. It can only pretend to have emotion and consciousness and so on. So I briefly explained, for example, emotion in ours. Basically, it's a mechanism to evaluate the current situation from the system's own point of view to say whether it like it or not, because whether it satisfies its goal or not. And also, it will use that information to decide its actions, for example, resource allocation and so on. Okay. Consciousness in ours, the primary form is the system to a certain degree know what is going on within itself. What task is working on, whether it's success or some failure, and whether it feels good or not, and what related to that feeling. And also that will have an influence to its future behavior. Okay. You can say this is too simple, too poor, which I fully agree. Okay, we're at the very beginning. You can also say that's not like human, which I also agree, which is right. Okay, because it has different body, has different experience. It should not have exactly like human in those aspects. But those things have the same cognitive functionality as the same phenomena in the human brain or in the human mind. And it just now we're just in a very preliminary form, but you cannot say it's impossible. Okay. So the other side of the story. So it seems I'm claiming that everything is possible. Of course, that's not the case. On the other hand, many people assume something will be done by AI, which I happen to believe is impossible. Okay? The first one, many people equalize AGI with the so-called singularity or superintelligence, okay? And say those kind of things are beyond human comprehension. As soon as you really realize AGI, then very soon we have not only out of control computer, they also have no idea what's going on, which I don't believe is possible. Okay. Because at least according to my working definition, intelligence is not magical. It's not magical power to solve problems. Instead, it's just an advanced form of adaptation. If we really build an idea according to this opinion, that actually prove we get this concept right. That means we really truly understand what intelligence is about. Okay, as many people have said, you don't understand a thing until you can build it, right? So if we build AGI, that means we understand what intelligence is about. The computer can do better because it's different experience, because it's computational power and so on, but it will work according to the principle we're building into it. Okay, so I don't call that superhuman intelligence. I just say, oh, its behavior will be different from us, and it will solve some problem better than us, which is already the case, right? Computer already solve a lot of problems better than us, but we don't call that super intelligence. We still understand the principle. Even though, when my computer runs into some issues, I have no explanation about what's going on, it's just because of the pure complexity. Okay, that already happened. So that kind of thing will continue to happen, of course, in AGI, but that doesn't mean they don't understand it's working. And I don't see that as a singularity. So to me, these two are very different, even though many people say, oh, they're the same. So that's something I don't think is possible. Another common, I will say, math is to say that AGI will solve all the problems that can be solved by human. So it's going to take over all the jobs from us, which make many people worried about it and talking about how to deal against it, how to regulate AGI, blah, 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 blah. You see, first, I don't believe in the pre-assumption of this thing. As I already said, I don't define intelligence as the ability to solve problems that only human can solve. Instead, I define it as kind of like a form of adaptation, which means what? Which means adaptive systems capability and behavior will be heavily depend on its own experience. So because computer will not have human experience, it will not do everything human can do. It's not a technical issue. It's not because it's not smart enough. Okay, just because it doesn't have the input they have. So the output will be different. So that's pretty simple, okay, in that sense. So to me, that of course, AGI will take over a lot of jobs. That's for sure. But I don't think all of them, especially those heavily depend on human experience. And also at the same time, AGI will create a lot of new jobs. And the other day I already mentioned it will create a new career or a field called AGI education. Right? We are going to need a huge number of teachers just for AGI systems, which does not even exist as a career. Okay. Anyway, overall, it's hard to say, but I don't think anyone can really prove AGI can take over all human jobs solely out of this. That's just based on a wrong idea about what intelligence is about. A related one. Some people say AGI, well, you're general purpose, right? You should do everything better than those special purpose techniques. So, for example, whenever we talk about the advantage of AGI, people always challenge us, say, can you beat deep learning in this or that task? I say, we cannot. Actually, I should add, that probably will never happen. Because the reality is the opposite. I actually have publication that talk about this. If a problem can be solved by a special purpose technique, usually that's a better solution than what can be provided by a general purpose system. That also explains for many things in today why we say computer already do better than human. Okay. Computer is focused only to that. Human have all kinds of idea in mind. You don't know, what will draw your attention, which will disrupt what you're doing. And also, computer are much more reliable, okay, than human for the same reason. Okay. And it's more predictable. You know what will happen. It will not try to be adaptive or to be creative, which is not always desired from an application point of view. Okay. So for all those reasons, I think people may take this as an excuse. Again, going back to my definition, I think we are not trying to replace or to win computation with any existing technology. Instead, we're working on a problem that few people have realized is a problem that deserves to be working. Okay, we're working on there beyond their scope. So it doesn't necessarily mean that it's going to replace their technique. Actually, I think it's the opposite. And which also lead to another thing, which I said several times in situations that people don't like it, many people, or people don't understand why I make that claim. That is, Mars currently, of course, we haven't finished. And even when we finish it, it will not be a commercial product. Why? Just think about a human. Can you make a human a commercial product? Okay. Here we are not talking about political or moral consideration. Even for practical consideration, just for the application purpose, that's a very bad idea. Okay, it's a very bad idea. So Mars overall is more after a theoretical goal than a practical goal. But on the other hand, part of it, or a customized version of it, can be used for practical application. Actually, in our team, recently we are talking about it, right? For example, how to limit the system's creativity or originality or curiosity, and whatever you say, okay, related to intelligence to a certain degree, so that I will focus on the problem you gave it. and only do things that are predictable or reliable, rather than trying things that radical or may not relevant. You don't know at the moment. Okay, for all that kind of reason, this is not directed in that kind of goal. Even though, yes, a part of it they're trying, and to make commercial product, I think it's possible. Especially in that aspect, especially we are targeting a market which does not exist yet. That is, a market you want to put a computer to solve a problem for which you have no idea how to solve. Do you have that product in the market? And people don't even think it's possible to put a computer there because you don't know how to solve it. And today's product is still basically repeating your solution, a human solution. But the NARS cannot guarantee that, but NARS still clearly is designed to work in that kind of system, in environment. So at least it gave it a possibility, okay, to find a solution. Well, on the other hand, the current technology will not have such a possibility in the first place. Okay, so that's the future target to me, market, application market, where I don't see any computation at the moment, even though, yeah, we are still far from. Okay. So the third question, how to do it? Well, that's what all the previous lectures are all about, right? So I'm not going to repeat the design of the system. Instead, I will talk about, from a relatively high level, talk about my overall strategy. You'll see that I have a goal I want to achieve, which I explained repeatedly. And then as soon as I decide I want to build a adaptive system which can work in an environment for which it has insufficient knowledge and resource, I pretty soon realize that there is no current technology that can solve that problem. Then what I've been doing, I try to develop that technology by myself. Okay, so this on one hand sounds kind of like natural, but on the other hand sounds very strange. Actually, I believe clearly I'm not the only one that in the field who run into this kind of situation. You want to do something, and you see the current technology does not give you the tool to do it. But what's the common practice? The common practice is try to improve existing technique here or there, so as to move closer to the goal. Using the terminology of reasoning system, you see, what I have been doing is more like backward reasoning, starting from the goal. Okay, I want to do this. So to do this, I see I need to be here. Then I will try to be here. And to do this, then I kind of like decompose the problem into smaller and smaller problems, and then try to build a solution to it. But the other strategy most people are following is usually called forward reasoning. It will start from what you do. You have, okay, the current technology. And they're wonderful. They have already solved a lot of problems, but it cannot solve the problem I want, which is far away. But I can still move in that direction a little bit, build on the current technique. Say, for example, make some improvement here or there, or combine some of the ideas together, move in that direction. You know, from a reasoning systems point of view, you cannot really say which one is better, right? Pure forward reasoning, the problem is very often you run into a dead end. You see the current technology doesn't really allow you to go that far because of their fundamental assumption. Okay, that's actually a reason why I developed something from scratch. It's not because I'm too proud to use other people's work. It's because I think it just cannot be used for the purpose I want to use it. But if you do it that way, of course, it's much more radical. It will take much longer time to finish. rather than compare to improve the more solid existing techniques. And it's more risky. You may actually completely fail, that you end up with nothing. Okay. So what I do is, of course, I still need to do it one step at a time. So that's why, if you read the book, you see I built this NARS in 9 layers, step by step, start from the simplest, absolutely simplest case, but it still follow the principle I want to follow, and try to make it a little bit more powerful in an incremental manner. Okay, so that's kind of like the overall strategy, and what makes this strategy different from the one that's followed by most people in the field. So I always say, okay, this AGI system typically consists of a theory about intelligence, which is described in natural language, then followed by a model, which is a formalization of the theory described in a formal language or symbolic or mathematical language, and finally by a computer implementation. So only when you have all three, you'll have AGI work. Okay, that's my judgment. Okay, so the details in all these 3 levels, I have got ideas from a lot of theories and the existing AI techniques. Actually, very often people, after they learn us, they say, "Oh, I see that there's some similarity between this one and something else." That's usually accurate, just because there are similarity between us with almost everything. Just talk about the big things. The AGI approach traditionally divided into so-called symbolic AI and connectionist or neural network AI. Okay? And for most people, if they only spend 10 minutes with NARS, they will say, "Oh, that's just another symbolic AI system." That cannot be more far from the truth. Okay, it uses formal language, yes. It uses formal inference rules, yes. But the philosophy, to me, actually is closer to connectionist, to neural network. And they have a huge influence, to my opinion. You will see, there's nothing fixed, right? Everything is learned from experience. And everything is uncertain. Everything can be changed. Okay. And the memory structure is kind of like a self-organizing map. And the meaning is, to a certain degree, distributed in the system rather than stored somewhere. And it does not use traditional semantics that a concept is a symbol of something. Okay, all those ideas come from neural network. I just don't like their technique. I just don't think you can build AGI just by a huge network, just send activation among the nodes and only do change the weight values and to do learning. I think that's too poor compared to what you can do with the symbolic toolbox. So in a sense, you can say that I'm using the philosophy of connectionist AI, but the technology of symbolic AI. Okay? But it's not just a mixture of the two, or in today's popular term, a hybrid of the two. I just don't think the mind, contains a symbolic part and a connectionist part, and they talk to each other, and they will work together. That's just, to me, that's just a wrong idea to think about things. Okay. But on the other hand, so even though you see, I don't want to just directly integrate part of other theory or technology into mine, I don't mind to use them as tools or a subsystem. We have already talked about that. In principle, we can use any existing technique in ours as a tool. For example, in our application, we use deep learning a lot just to do processing for visual signals before we develop something by ourselves. Right? That's perfectly fine. But that's different from using it as part of the system. So also you'll see I have criticized probability theory many times during my lecture. I just say that's not the thing that AGI should follow. But on the other hand, I don't mind. I think it will be necessary in the future for NARS to learn probability theory. So it becomes a subsystem, so it will be applied wherever the system finds that a situation and this problem really need to be handled according to probability. Okay, that's perfectly fine. So that's also consistent with my previous description about this meta-level intelligence versus problem-specific skills. Okay, so a metaphor I mentioned before is you can think NARS as an operating system. The other techniques as applications. And you use this operating system, which is general purpose, and to run those applications, each of them is specially used for one tool, for one task. Right? Even though here the metaphor is not perfect because the operating system itself can be directly used to solve some problem. But even if that's the case, it usually doesn't work as well as a special purpose tool under the condition that that tool is applicable in a situation. So you'll see that on one hand, I'm not saying that NARS is everything you need. Clearly, that's ridiculous. On the other hand, I don't think, just because a technique is very successful in certain things, you should integrate that as part of NARS. That doesn't work. So that's kind of like the methodological ideas I have. A little bit practical, a little bit more concrete description about methodology. You see where I start more actually at the theoretical level. So that's the problem that troubled me many years at the beginning when I started to have this idea. That is, if you force the system to work with insufficient knowledge and resource. Actually here, this is what I mean by realistic situations. Okay, realistic situation compared to the current situation assumed by many models has the property of exactly the property of insufficient knowledge and resource. Okay, it's not talking about concrete details here or there in each situation. It's kind of like the traditional model assumed too much. So if you give up that assumption, it sounds simple. Okay, everyone will say, we prefer a theory that can solve practical problem. But in reality, you know that as soon as you take that approach, you'll see that the traditional standard cannot be satisfied anymore. Like as I said, there is no absolute truth. That in what sense your solution is better than other people's solution? Both can be wrong. And you cannot even promise to have a higher probability to be correct. Okay? In what sense? So this problem needs to be solved before all the technical issues, because you need to set up a new standard. Okay? So this is basically in the same direction as Herbert Simon argued many years ago about bounded rationality. Okay, so clearly my ideas are inspired by him to a large degree. But the problem is he didn't give out the details. He just said, yeah, we are bounded. Well, of course, because of that, we cannot be perfect. And he suggests, you're not looking for optimum solution. You're looking for a satisfying solution. It's good enough. Will be good enough. But the problem to me is even that is asking too much. Okay, for many problems, we don't even have a good enough solution. That's what we do. Okay, so what I gave also, there is nothing magical if you think about it, is quite common sense. It's basically you just get whatever you can get under the restriction of available knowledge and resource. Okay, under this restriction, find the best. So you can still call it optimum, but it's optimum under a lot of restrictions. So if I put it in this way, I think many people will agree. Yeah, of course, that's what we do. What else you can expect? Okay. But in practice is how to realize that kind of thing, how to describe that, yet using a technical terminology. Okay, how to actually realize what is the measurement about, what is the current restriction and how can you claim this is the best you can get under that restriction. So you'll see that what I tried after some comparison is to take the reasoning system approach. It's not because I don't know the issue of traditional symbolic AI. It's because I think at least this one tried to approach the problem at the concept level rather than at the neuron level, which I think is wrong in the first place, okay, for the purpose. Concept here is you're capturing part of your experience in a limited manner, in an abstract manner, which is bounded already by your previous experience as far as your current research. And then you use that to try to handle the new situation, which will actually explain some traditional concept like what is the meaning, what is the truth value. You'll see that in ours, all those things are defined as a property of as some property or feature of the system's own experience.
Maybe he has to change the slide.
Oh.
Yeah, we have no OK button.
I press the HDMI.
Nice.
Then based on that idea, what I have done technically is try to reform logic. Okay. It's kind of like try to bring logic back to its original meaning. The original meaning of logic, everyone knows, is about regularity or law followed by human thinking. But in recent years, or hundreds of years, it become dominated by the study of theorem proving in mathematics, which of course is valuable, but it's actually a very special case of thinking. It's highly idealized. Everyday thinking, you need to deal with all the messy reality aspects. Okay? You don't have axiom to start with. You don't have the resource to just try to prove a correct theorem without thinking about how many steps it takes. So, but I still think the concept of logic or and overall framework is still valuable, not like the criticism, the people who criticize symbolic AI. They typically criticize it to say, okay, you're wrong because human mind doesn't follow logic at all. And the example they use is what is the examples against the first order predicate calculus. Okay. But clearly, that's not the only type of logic possible. So what I'm trying to do is to keep the idea of logic with formal rules, but interpret the formal in a slightly different way. Does not mean that have nothing to do with semantics. Okay, it can be both formal and have something to do with semantics. And also you'll see that traditional logic is binary, which clearly is not enough for our purpose. It's deduction only, which is clearly not enough for our purpose. And also it's typically only work on atomic terms. That is, every term there is a name of something, and that's not good enough because AGI system, as we have seen, need to create new terms by itself. start as some kind of compound or structure or combination of the existing one. Okay. So all those kind of things are missing in the traditional logic, but I think it's possible to add it back in. Well, clearly, I'm not the only one who have tried this kind of thing. Many people have tried, but they typically try it one at a time. Okay, so they're multi-valued logic, which just want to change the binary feature, but they still want to keep it deductive. And some people do inductive logic, but they still try to do it within the framework of binary reason. That's interesting. And also there's atomic term. Many people think that's a separate problem. You don't have to touch if you are doing induction, right? So it's kind of like divide and conquer strategy, widely used if you check the so-called non-classical logic. And there are many of them. Each of them just address one issue. But to me, all of them actually have the same root. That is, you're talking about the logic in the sense of everyday thinking, not in the sense of mathematical theorem. And then all those problems will appear altogether, which should not be solved, try to solve one by one, just because it's kind of like symptom of the same disease. You don't cure one symptom, you cure the disease itself. Okay. So to me, actually, I think that in the future, I can convince the people to solve them all together actually is technically simpler than only solve one of them and leave all the others there. Just like, again, there's a metaphor. Okay, just cure one symptom of a disease and leave everything else there. That's actually harder than to cure them all together. It's just because there is a much deeper reason for this problem to appear. And then finally, the control part, which is a long story, which in this course we only touch the basic. But the issue is the one that I already mentioned. How to handle a problem for which you don't know how to solve, which sounds like a dilemma, right, or a contradiction. If you don't know how to solve, how can you solve it? But on the other hand, that's what we are doing every day, right? We're working on problems for which we have no solution. And that's what really makes intelligence different from routine work, or what we call mechanical solution. Okay. So what R does in a higher level actually is also common sense. So what do? If you run into a problem for which you don't know for sure, well, of course you need to know something, right? If you know absolutely nothing, then otherwise hopeless. Clearly, that's also not the situation we're talking about. We're talking about is you know something, but not the complete story. And also what you think you know can be wrong. But still, the strategy now starts, again, in common sense is try everything you can think about in parallel or altogether, but at a different speed. Because you don't have all the resource to explore all possibility, so you distribute your attention among them according to your current evaluation about their importance, plausibility, urgency, and so on. So if for a given problem, you have, say, you can think about 3 possibilities, then you explore them, but not treat them as equal. You may spend 60% of the resource in approach A, 30% in B, 10% in C, but you reevaluate their progress from time to time, then you adjust your distribution. And still, there's no guarantee you're going to find the best solution, which may be completely beyond your capability. Okay, but that's the best thing you can try, according to my definition. That's the best use of your existing knowledge and resource. So everything else are just details. Okay, so this is the idea. And finally, let's move to the last big question, which we didn't say much, but now it's quite hot. Wherever we talk about AGI. So many people say AGI is very dangerous. It's actually a risk for the existence of human species in the future. Okay. Just because, well, we dominate the world because we are smarter than everyone else. Now, if there is something smarter than us, well, we are in trouble. Well, that's a common sense argument, okay, which is understandable. Many people are concerned about that, and also, helped or supported by argument from Hollywood movies with some kind of sci-fi stories, which is understandable. But on the other hand, if you analyze those arguments carefully, you'll see that, as far as I can tell, all the arguments I have seen so far have some fundamental misunderstanding about what intelligence is, what computer can be, and so on. Okay, which is some of them related to what I have already said, which I will not repeat. But do we have an issue? Of course, we have an issue. I'm not saying that all those concerns or worries are completely misconception coming out of nowhere. We do have ethical and moral issues, which actually part of it is not owned by AGI alone. It's actually belong to every technology. And in recent years, a lot of discussion about for science overall. Okay. On one hand, it solves some problem. On the other hand, it always creates new problems. No exception, no matter which branch you're talking about. Okay. In that aspect, of course, AGI is not an exception. So we share the same issue. For example, every technology has the danger of being misused, okay, by the bad guys to do bad things, or to be abused by the good guys to do stupid things, right? Which they just fail to see the consequence. Okay, can we avoid that? We cannot. I don't think anyone can avoid that. But that's not really the interesting part. The interesting part is there anything that really made AGI different in this discussion compared to the others? Yes, there is. But I don't think the place is when the people talk about in terms of, say, superintelligence or singularity, they think the major difference or the major danger is the computer become more intelligent than us. I don't see that's the right issue. First, according to my theory, AGI will not be more intelligent than us, will be as intelligent as us. But they will be more capable in solving certain type of problems. On the other hand, we still will be more capable at solving some other type of problems, because the difference is not in intelligence, as I said again and again, is in experience. So I'm not worried that in one day computer will be more intelligent than us. On the other hand, if it's more capable than us, that's really what we want. Okay, that's what we want a computer to do. We want to use them to solve problems, which they can do better than us. That's a better thing. So to me, the real danger is what? Is adaptation. Adaptation means what? An adaptive system is different from a non-adaptive system, not in its problem-solving capability. Is in its capability is not completely determined by its design, but also by its experience. Okay, so that's why here I said is a plasticity and a nurture, that is, after you finish your design, you still don't know what will happen to it because it depends on what happened after that. That to me is the key difference between AGI with almost everything else. That's also related to what I said, why NARS will not be a product. Okay, for almost all other technology, when you finish the product, there is expected a reliable performance or function or capability, whatever you call it. Okay, there's still a danger of misuse or abuse, but there is a basic functionality. If the system is truly adaptive, you don't have that. Just like a baby. Okay, what a baby will grow into is not determined by the initial configuration, DNA or anything else. It's influenced by it. It's mostly determined by its experience afterwards. So this is the big issue because in recent years, we keep getting requests to say, yeah, we will allow you guys to do your AGI research if you can guarantee your product will not damage human beings. We cannot, just for this reason. Okay, you just like a metaphor I often use is you cannot require parents to guarantee their children will not become criminals. There's just no way for that promise to be made. It's not to say that the parents are not responsible. That's not within your control. And many people still don't see it. They still think AGI in the terms of just kind of like a more and more powerful system than the current one, even though they can still be, their capabilities still can be controlled. For example, many people talking about the super goal. It's kind of like if you set the super goal right, the system will only try to achieve that goal. And if you run into trouble, and it's because your super goal is not properly set. I think that completely misses the point. You can provide some initial goal into the system. You can call it super goal, okay? But if the system is truly adaptive after a while, that goal will not completely control the system's behavior. And it should happen, actually. It's not a bug. That's a feature. That's what adaptation is about. Like us, we decide our own goals. But when we say we decided, we're not meaning that they're coming out of nowhere or coming out of a random number generator. We mean where motivation system is shaped by our own personal experience. That also sounds like common sense. But that common sense has not been taken into this discussion. Okay. So I said, no, I cannot promise anything. I cannot promise that NARS will grow up into a nice guy. It depends on its education. Okay, and many other things. So eventually, you see, intelligence and morality of a system are largely independent of it. Again, this is kind of like common sense. Many people have said that, and also many people have learned that from their experience. That is, a more smart person is not necessarily nicer or more evil. It can be either. Okay. So there are two analogies, and there are two separate things. And also related to what I said. According to my theory, the intelligence is mostly determined by the design. But morality and the other things are mostly determined by the nurture, not by the nature of it. Okay. So what's the solution? Well, I will say, well, again, this is common sense. It's not a single magic switch, okay? You can just turn and you can guarantee its safety. So it will be a combination. Of course, design matters. You don't want to design a crazy system, right? Which is completely out of control no matter what. And also, like we also talk about configurations, like give it a body and give it proper sensors and actuators, and set up the parameters properly rather than to have some kind of like very extreme personality. Okay, so you don't want the system flexible, just from one mistake made by one human to generalize to the conclusion that all humans are evil. Okay, if the system do that, then of course it will not be safe. So all those kind of things need to be taken into consideration. Also, education will make a big difference, which we discussed last week. Okay, so in the early stage, we should put the system into a certain environment. We will carefully feed it the proper knowledge so as to shape its motivation structure and the beliefs about the society, believe about the others, believe about its religion or its own position in the society and so on. Okay, and but even education itself doesn't solve everything, because after that AGI graduate from the school and will still have a new experience. That's what we call socialization. Okay, and finally, on top of all those things, we can even design evolution process for the whole species of AGI, as I discussed last week. So, do I have a perfect solution for the morality or safety of AGI? Well, I don't, but on the other hand, I don't say we are completely hopeless. I will say this is the same thing as human beings. We don't have a perfect solution to solve the problem we have. But we do have something. Okay, so it's not all or nothing situation. And also, this problem will continue to exist. Just like a computer security issues, right? You don't have a perfect solution which can block all future issues in computer security. So it's basically, we grow with it. Whenever we run into new problem, we try to find new solution. After we solve those problems, some other issue will pop up. Then we'll continue to work on. Okay, that's the same thing, I think. And finally, some people will say, if you cannot guarantee the safety, why take the risk in the first place? Because, yeah, I agree. AI can be very dangerous. So if you cannot kind of completely avoid that, maybe we will just stop. Okay, you guys don't just do it just for your own fun, right? It's risky. You don't want to play with fires and so on. I think there are a lot of reasons, but two basic reasons to me. One is a theoretical reason. AGI, as I already mentioned, is not an attempt to build a computer to replace humans so that some big company can make more money. At least that's not our purpose. Okay. From a theoretical point of view, we're building a model, try to kind of like check different theories or to find a theory which can explain what we call thinking, cognition, mind, mentality, or whatever you call it. And this can be dangerous. But if you think about it, if you ban this, I will argue for the same reason you should ban the whole psychology, the whole logic, the whole philosophy, and many other fields, neuroscience. Okay, AGI is not that different from the other fields. We just use a computer as a platform to test all the theories about how thinking process works, which is a study or an interest of human beings from the very beginning of human society. Okay, even the first generation of philosophers begin to think about, know yourself. Okay, that's exactly what we are doing. Can you say is that dangerous? And can we just ban it? We cannot. And for the reason I just mentioned before, You cannot just say, okay, prove you're safe, then we can allow you to proceed. Actually, it's the other way around. Okay. Many people who kind of claim they have a way to guarantee the safety of AGI are typically based on very technically invalid arguments. They don't understand what they're talking about. Okay. If you want to make it safe, you need to know how to build it. So I don't think that's a reason to stop it. Actually, this is actually a reason to promote this research. And also there is a practical reason. Again, it's not to replace human labor. Instead, to me, is to solve problems that human cannot solve at the moment. There are many problems which either the complexity is beyond our capability, or the situation where it happens is something we cannot reach, and so on. Okay. For those situations, we do need intelligent machine, which will make, actually, when people talk about the safety issue of AGI, I want to remind them, not only think about the danger or the new problem AGI may create, but also think about the existing problems that AGI may solve. Okay, then what? Then you balance the two. For example, many people have already mentioned in recent years, like a nuclear power station failure. Okay, if you have a smart robot, you can send it in and may be able to fix it, which a human, you cannot do that. And also, if you send something to Mars, maybe it's better to send a robot first than a human being. Okay? So for all that kind of consideration, we are talking about problems which has the nature of insufficient knowledge resource, and which probably can only be solved by a computer system which can handle that. Okay, to me, that's really the practical need for AGI, rather than just to replace employees for a certain company. So in the end, this is a matter of, you balance the positive and negative evidence, just like everything else. To me, there is much more positive evidence than negative evidence for us to continue this research. Okay, and I welcome other criticism and other opinions as far as, at least first you need to know what we are doing. Okay, many people criticize AGI, but they're actually criticizing a straw man. For example, some people, just recent YouTube video, some people say, oh, that's a joke. There is no such a thing called general intelligence. Even human intelligence is not general purpose. Oh, that's not what we are talking about. Okay. No one well, at least my team is not taking AGI in that sense. So your criticism doesn't really make any sense to us. That's your misconception, and you don't even bother to check what the other people have been doing. That's your problem. But still, we are open to criticism. So finally, this is the last slide. Where we are? Well, for the field of AGI, we are still in a stage where there are many different opinions about what should be done and what is the best solution and so on. I don't think we can convince each other. Okay. Even my work, I do not expect it to be accepted by the majority of the field. I understand why they don't like it. Okay, for this or that reason. So this situation will continue for a while, which actually is normal for a field which is dealing such a complicated problem. Okay, so don't expect, very soon we have AGI theory or AGI technique accepted by everybody. Unless they create a very impressive demo. Okay, now many people, they don't really want bother to study your theory. They just want to see your demo, which is not always easy to make, or some of the impressive demos are actually quite misleading. So it's a tough situation. How about for NARS? For NARS, I'm quite optimistic, especially the progress in recent years are much faster than before, just because previously I'm the only one working on it. In recent years, we have a lot of people, but not a lot of people, but much more than one single person, right? And we're making very good progress. So I'm optimistic about it. But on the other hand, you'll see that we openly admit there's still a whole bunch of issues we haven't fully solved, and we're working on them. And finally, we welcome all forms of involvement and cooperations, and feel free to contact us. And that's it. And this is the video that of my talk here, where I just arrived, also talking about the basic questions, but it will be much less complicated than my presentation today. And also these are the concluding chapters of my books. And also there's a website of myself, my team at Temple, and the team here is which provide additional information. Okay, for the first time, I'm finishing on time. Yeah.